Hello? Okay, so good morning, everyone. Today we are going to talk about Lab 3, real-world data, and mainly about the pre-processing of real-world data. And this lab is required submission, and the submission link is already here, and the deadline is 10th of February, next Monday, midnight. So, I mean, yeah, 95 past 23 o'clock. Okay, then let's look at the codes here. So similar with the previous labs, we have two sections. The first section is some demonstration, okay? And then the second section is exercise that you need to do by yourself and then submit it. But when you submit it, please submit the whole file of the Jupyter notebook type. Okay, then let's go ahead. So firstly, if you still remember that we've talked about handling missing data in the lecture. And here I'd like to give you some example. So firstly, we create a string. Okay, so this is a string. And we can see we have 4 different lines of 4 different rows. And the first row represent what they call the labels. And then we have the corresponding value for each column and rows. And here it asks you to first read the CSV format data into the pandas data frame. So if you still remember about the things we learned last class, we need to use the library and the method of read CSV here. And then we put the string here, but you know that we cannot directly read a string as a file. So we need to firstly use this function, string IO, to convert this string into a file-like object. Okay, so because this method here, read CSV, can only read file, so you need to convert the string into a file-like object and then change it to a pandas data frame. And the string IO method is from the IO library. Okay, so when you are using this function here, you need to first import from this library IO. Okay, then let's see the, okay, we need to put the, yep, here, print it, yeah. Okay, so this is like the data frame. We have 3 rows and 4 columns. Okay, and yes, the first row of first line here is the label, and we have a data here. And if you pay attention here that we have some empty space here, like here and here. here for the end. Okay, so we have some empty. Okay, no, okay, 1, 2, 3. Yeah, this one. So here we have 4 numbers. Here we only have 3, and also here the last row we also only have only 3. So this is the missing numbers, and then it is encoded as a noun. Okay, and not a number means not a number, and not a number. And then how we deal with these missing numbers? Firstly, we can just like check if there are missing numbers in this data frame. We should use this is no or not no. Okay, so let's say this is also a method included in this lab is okay. You can directly perform this one, and then it will show you the choose and false list table. Okay, so when you are using is not, okay. So when the place here shows you that it's true, it means this is a missing value. Okay, and but if you are using like not now, then it will be opposite. When it shows false, it means there's a missing value in this place. And also we can use some function like to return the number of missing value per column. Okay, we just need to add another method after that sum. Okay. Yeah, and then it will give you, oh, this is not, no. So yeah, so it will give you the missing values, shows you the missing value per column, the number of missing value per column. So we can see like we only have one number of missing, one number of missing value per column. So it will show you that in each row, how many missing number are there. So if we do like this, we did one more here. There is one more value here. And then we run the code here again. We'll see that in this row, there's one more missing value. Okay. Then how we deal with these samples, these missing values. So in the class, we say we can eliminate these kind of missing values. So actually, the simplest method is that we use the drop now, the drop an A, okay, here. Mm, Wait, oh, so because I delete all the numbers here. So let's see what 0. Okay, because I have all the rows here, I've put a missing value. So when I using this function here, it drop all the rows. Okay, so let's say we only have 2 rows that has missing value, and then we use this drop an A, then it will drop the rows that has missing value. Okay, And then this is by default the rows. You can also drop the columns. You just need to set the axis as 1, okay? So by default, the axis is 0. And when it is 0, it means the rows, okay? They are equivalent. But when we set axis to 1, then it means to check the columns. So it will drop the columns that has missing values, okay? So you can either choose drop rows or columns. So rows means the samples. Columns means the features. And we can also set a threshold for the columns or lines that we want to drop. Okay, so let's say we drop the rows that haven't at least 4 not a number values. Okay, and we just need to put the threshold. You can see this arguments inside threshold equal to 4. Then it will drop drop the rows that haven't at least 4 missing values. Sorry, non-missing values, okay? But if we set to 3, then we can see it didn't drop anything because every rows, they have at least 3 numbers, 3 values, okay? So you can put the threshold here. And we set 4 because this first, or we see this second line and this third line here, they have missing value and they only have 3 elements inside, okay? So when we set 4, they will be dropped because the first row is the only row that has 4 values. And we can also set like to only drop rows where the missing value appear in a specific column. Okay, for example, let's just copy paste it, and we set the subset using subset. Let's see C. Okay, so C is the name of the column. Yeah, so we can see here. Let's see. Look at the original data. So we have a missing value in the column of C, right? And then here we just want to drop the missing value, the row of the missing value, where the missing value appear in the column C. Then drop the first line, right? First row. Here. The first row we have a missing value. We have missing value at the column C. So we'll drop the first line, first row. And if we choose D, then we'll drop the second row. Okay, or the third row. I mean, the index here is a bit confusing, right? So it's a bit hard to explain, but yeah. If see, you can see that 0 and 1 here, right? If we put D here, this is the line at the row of 0 and the row of 1. But if we put C here, then it's the row of 0 and the row of 2. Okay, so it's drop the row of 1. Okay, row of 1 has the missing value at column C. Okay, and row of 2 had the missing value at column D. So when we set to D, then it will drop the row of 2. Okay. Yeah. So this is how we drop to eliminate the samples of features with the missing values. Okay. So again, usually the columns means the features, the A, B, C, D represent for different features that we have. And the rows means an instance or a sample. Okay, each row represents for a single instance or a single sample from the data. And also we can do imputation, as we've talked during the lecture. And here is an example of doing imputation, okay? And so we can have a look here. So firstly, we need to use the sklearn, okay? sklearn library. This we will talk about like in the later lectures. Actually, imputer is just a model. So we import a simple imputer, okay? The method is called simple imputer. And then we create an object of the imputer. And then we set the missing value as not a number, okay? And then when we do imputing, our strategy is using the mean value to do imputation, okay? This we've talked during the lecture, how we do imputation. We have different strategies. We can use the mean value of the neighboring data, or the median value of the data, something like this. So we create an imputer here, okay? And then we fit this imputer to the data. df is the data we have. So this is like kind of training, okay? So just like when you're doing linear regression, you need to feed the data. And this is a similar process. We fit the imputer to our data. And then we use this imputer. After we fit the imputer to our data, we use this imputer to transform the data values, which is not a number, okay? So transform the missing values. So df.values means the values inside the data frame, okay? And then we check the imputed data. Yeah, so we can see here, the original data is 568, right? So when we are calculating the mean value, it's 7.5. Yeah, so it's the mean value of these two, okay? So it's dependent on the samples. So the first sample we have is 3. Another sample we have is 12. So we are doing like the mean, we calculate the mean of 3 and 12, which is 7.5. And then we use this 7.5 to replace the missing value as a guess of this missing value. Okay. This is when we use how we use imputation to imputing missing values. Yeah, we can check. Yeah, we can check the original data here, right? This is our original data. And also like we have a missing value here. And how we impute this missing value, we also use the mean value of these two samples, okay, which is 4 and 8. And their average, or the mean value of 4 and 8 is 6. So we impute this missing value by 6. So this is how we impute missing values by its mean value of among the samples. Yeah. And also we need to handling the categorical data, because let's say sometimes the samples they don't only have numerical data. They also have some string as the features. And you know that the computer is not able to recognize a string when it is doing calculation. Okay, so you need to convert the string into numbers. For example, here, let's say we have a new data frame. Okay, so we have different kind of features here. Okay, so it's like maybe some trousers or t-shirts, something like this. Okay, so we have different colors, size, price, and the class label. Okay, class label is just an example to show you that there are different classes. And let's say price here is okay because it's numerical data, but the size here and the color here, they are string data. So let's take the size as example here. We need to transform this string into numerical data. So the simplest way is that we use some integers to replace them. So we create a dictionary as a mapping from the original data to the integers. Okay, so for example, we want to replace XL as size of 3, L as size of 2, and M as size of 1. Okay, so this is like how we want to do mapping. So this is the mapping from the XL, I mean the size to integers. Okay, and then this is the original data. And then what we need to do is to transfer from the integers value. Okay, wait, we didn't do transfer yet. Yeah, so we need to transfer here. Okay, so what we can do here is that we get the size column. Okay, for data frame you can always call the column based on their name. Okay, so we use the size column here. And then, yeah, again, we use the size column. We use the map. We have a map function here. And then just we put dictionary inside. So here is how we want to map the values to integers. And then we put this dictionary into this map function. Okay. And then we just replace the new values. Sorry, we just replace the old values by the new values here. Okay. And then we can see what happened. We can see we changed the XL and LM into 1, 2, 3. So it's already changed. Yeah. Okay. So MLX has been changed to 1, 2, 3 here. Then the computer is able to learn from these features. You can also change the color in this way. See, color. But in this color, we have green, red, and blue, right? You can also change them to 1, 2, 3 color. Yeah, so you can see now the color and the size are all changed to numerical data. Then you can input this kind of data into the machine learning model to train the model. Okay. And then how we this is ask us to transform back, reverse it. Okay. So we can use the lambda function that we talked about in the first class. We just change the order vk into kv size mapping, size map dot items. Okay. So size mapping is the dictionary here, and then we get the items inside. Sorry, we get the items inside. The items are these things. Okay, and then so key and v here represent the first element here and the second element here. Okay, then we just change this key and v in a reversed way. Reversed way to v and k. So then the size mapping will become 3 colon green, something like this. Okay. And then with green size, I think height. Okay. Size map, inverse mapping. Yeah. Yeah. Now we change back to the color, right? Blue, green, blue, red, green. Yeah. Oh, styles. Oh, sorry. Yeah, yeah. We changed the color. Here is the mapping. We were using color. Okay. So this was still the previous one. Yeah. Then we check the DF. Hmm? Oh, 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 sorry, sorry. The original. Yeah. So here, like this. We change the color back to the from the 3 to 1, we change it back to green, red, and blue. Green, red, and blue. Okay. And in your script, it should be the size. Okay, just change back to size. Size is MLXL. MLXL. Change back to the size. It doesn't matter. Size. Create the data frame again to put everything to the original one. Okay, then we change the size to 3 to 1. And then size change back to MLX. Okay. Oh yeah, we already changed it, so we don't need to. So this program you can only run for one time. Okay. If you want to run it for another time, you need to rerun from the beginning. Okay. You need to define the data frame again, and then start it from the beginning. Because the map here is from M to 3, right? And once you already convert it to 3, and if you want to do this mapping again, it cannot find any value of M, X, and XL. So it cannot run for the second time. Okay. Yeah, this is how we do how we deal with the features, the categorical data. And then another thing we need to do is to encode the class labels. Class labels. We also need to create a mapping of class labels. Okay, and we can actually have the code in the lecture note that we change the label in this way. For index and label in enumerate. NumPy. I've introduced this unique function in the lecture. EF, we find the column of class label. Yeah. Oh, sorry. Okay, so like this way. So firstly we use the unique function to check this column, the class label column. Okay, the class label column is like this. We find how many unique classes there are. We can see here we only have class 1 and class 2. So there are 2 different unique classes here. Okay. So then there are only 2. So then we see what will happen. So it will only give you 2 values. The first one is 0. The second one is 1. Okay. And then again, we create a mapping, right? Then we just doing the same thing as we did in creating in converting the categorical data, sorry. Class label. So we use this map again, okay? Map the value according to the dictionary that we create. The dictionary is the mapping relationship. Right. So we get this column of class label and then map it to 0 and 1 according to this dictionary that we create here. And this dictionary is based on the how many unique values in the class label. Then let's run it. Class label. Oh, sorry. Class label. Yeah. Then we can see here we changed the class label to 0 and 1. Okay, so class 1 represented by 0. Class 2 represented by 1. Okay. And we can also reverse this change by the similar method that we used in the previous section. We just use the V and K is like, doesn't matter. Okay, you can use any kind of variables here. KV. The point here is just to change the order from VK to KV, from KV to VK. Okay, like KV in class mapping class mapping dot item. Item. And yeah, that's equal to the DF class label dot map. Use the map function again. And then we use the newly created dictionary, which is wait for it. Okay, there we go. Yeah. Then we can see we change it back to the classes. Class 1, class 2. But in the machine learning, we need to use classes in this numerical number, okay? You need to change all your data into the numerical number before you input it into your machine learning model. And here it gives you a label encoder. Okay. We have a simpler method that we can directly use the label encoder. Okay. So it is a library in the sklearn. And then we create an object of label encoder. Sorry, label encoder. And then we fit it with transform. And again, we call this column here. Get the values. Yeah. So here's a function, okay, of the label encoder. So it can directly perform all the things that we did here, okay. But actually, you don't need to practically, you don't need to do in the way like this. There are a lot of different libraries provided for you to encode these target labels into the numerical data, okay? So this is like just give you the idea how this kind of encoding of these class labels work. And practically, you can directly use some libraries that it provides you the method to encode these labels. Yeah, and also it has an inverse transform. You just need to use this method, inverse transform, and then it will transform back the data to the original one, which is class 1, class 2, class 1. And then here we just encode it into 0, 1, 0. Okay. So this is about the pre-processing of data for some, for some examples. And now you will have 10 minutes like to try to work on the exercises. And so there's a new CSV file provided for you. You can download in the OLE Titanic. Okay, this is a dataset we've talked about during the lecture. So you can use this Titanic method, Titanic data to do the exercise. Yeah, just some very simple exercises. And the deadline is 10th of February, so next Monday. Or before Tuesday, okay? Before 0 o'clock of Tuesday. And just for reference, I'll save this file and then similar as last time, I'll input it in the OLE file, download. Yeah, file. not change the name. Thank you. Please answer. Okay. Okay. So you can do exercise, and I will upload the answers for the first part into the OLE. Yeah. So here I've already uploaded the answers for part 1 in week 4. Okay. So if you didn't follow during the class, you can just download it and have a reference for your work. Okay, so here's the end of this class, and thank you very much. See you next week. And yeah, here's the attendance.